because it's really hard to see that flame, maybe this will help you. Okay. So I'm just going to put a little bit of a squirt of methanol in here. Seems like a good squirt, right? And then moving it out of the way so that cam doesn't get exploded, because that'd be sad. Not a good way to spend your spring break, right? In the burn unit. Nobody likes that. And now we'll combust it. Things don't always just react, right? And you should have seen that. They need what's called activation energy. You need to give the molecules enough energy hitting each other that they'll actually start to react. So for stuff like this, or like the methane coming out of our tubes, matches, fire tends to work pretty well, right? Seems good. Did you catch it? Is that too fast for you? And so what normally happens, I can. It'll take me a second because now the bottle no longer has methanol or oxygen, right? So I've got to get all the CO2 and water out of here. Yeah, could you tell it was all well mixed this time? Yeah. Yeah, and so it just lit. This is when, by the way, that people who aren't paying attention blow up their front row. Because people will be like, oh, do it again, do it again. They're like, yeah, let's do it again. And they'll grab the methanol and pour it in, not realizing that the flame is invisible. And so it's still burning and it lights them on fire, and most of the time, actually most of the time it just lights the front row. They tend to make it through just fine. Because it explodes outwards, right? Because I'm holding it here. So when it goes, it goes. I actually had a student of the dad who burned up his front row when we lived. I told that story. He's like, that's my dad. I think he was a little embarrassed. So he was like, oh, that's my dad. And I was like, I know. That guy sucks. And for the record, in case you're wondering about things like law, no, he did not get in trouble or sued. As a teacher, you're immune from stuff like that as long as you are doing your job. Government employees have immunity from such things as long as they're doing what's supposed to be done in their job, right? That's why people get so grumpy when police officers shoot people, and they're like, they should be arrested for murder. Really, really hard to arrest them for murder because they're actually doing their job and they're government employees. You follow that? So if you've ever wondered how those cases get thrown out so much, that's actually why. So as a chemist and a science teacher, it's kind of my job to blow things up. That means sometimes other people get blown up too. So sad. Might have to delete this video. No, I don't even know if we're missing anybody today, are we?
Yeah, Jim.
Well, Jack, if you're watching this, have fun. I think we got most of the water out, maybe? Yeah. You don't think?
Probably wouldn't.
He's super excited right now. Oh man, I can't wait for what you're supposed to. While he's on spring break, that's what I'm going to
He's just missing first hour.
He's doing a job show.
Oh yeah. So
He specifically chose me to miss. And my fire. Sure. So I'm trying to make sure all the water's out. By the way, there's nothing on the sink now, so this explodes. You gotta catch your hair. That stinks. So try again. Are you actually ready this time? You think it'll work this time? A lot of times I can't get it to work because it's not well mixed the second time. Look at you guys all taping. There's another camera here.
Best moments of your life, not on the phone, guys.
All right, you ready?
No.
Did you hear it still going? Yeah. Why was it doing that weird, like, what was going on there? Yes, I purposely did it slower that time once you could get a good video, and two, so you could hear that. What was going on there? Hmm? Why? Why did it keep stopping? What did it run out of? Yeah, it was having to suck in more oxygen, right? So you kept hearing this because it was going out, the combustion was stopping, and then more oxygen would pour in, and so it recombust again, to be able to do it. So you hear and so it would do that, right? If you also were paying attention, did you see the flame go down the tube? Right, so as it reacted, it kind of traveled the tube. The first time I just dropped the match in, right? So it started like kind of at the bottom, did all of it at once. This time we purposely started up here so it's a slow burn, so you could kind of see it. But again, this is all about those ratios again. And this is just a good way of showing it. If you're wondering, this is called a whoosh bottle demonstration because it goes whoosh. Chemists, like I said, aren't crazy creative. I'm very glad in case the sink didn't blow up on me. I was only mildly nervous about it. Not so nervous that I turned on the water to wash it down. But, nervous enough that I thought it could be a possibility. But I thought it was worth the risk. Should we try one more?
Yeah.
What do you think? You want me to drop it? Well, if I've gotten all the oxygen, right? Because that's the problem. I want to make sure we have enough in there. If it doesn't work, that would be the reason. Am I still waiting?
No,
Cool, yeah? Did you get good vids? Put it on your Snap story. I went to a presentation a couple weeks ago where they told me I needed to start Snapchatting for my students because that's how they all communicate. They're like, it's way better to just do it that way, blah, blah, blah. And I'm like, I'm really lazy.
Snapchat compared to what? Emailing?
Like just extra. Yeah, but emailing homework was a big one. Like the teacher would be like,
how do I do CH?
he'd be like, click, here's your stuff from today. Stamp it out. Or people would send him a question. Like he was showing like screenshots. Here's questions people sent me. And I'd write them back. Or if he was like an economics person, so like he'd be out and he'd be like, oh look, this thing's on sale for 1 cent. But he changed the price, which is a normal trick. And so he was like taking a picture and snapping it out to his students. I was just like, I don't know, maybe. I'm really kind of lazy to take pictures though. Other people are not. Like you. I am way too much. So how do we use this stuff? Well, we're going to start easy today, just looking at these ratios. But secondary, the way we'll do it, and let's start still kind of basic. Let's say somebody said, hey, you got, I don't know, 35 moles of this, right? And they'll say, how much oxygen do you need? Or how much carbon dioxide will you produce? Right? That's pretty common one, how much greenhouse gas you'd get. So they'd say, hey, how would you do that? Well, the math is not hard. If it's a 1-to-6 ratio, and I said it was 35 of these, how would you figure it out? 35 times 6. So the math isn't hard. The way I suggest people do this, and you'll see this all unit long. In fact, one of your assessments, like quizzes, I only look at what you write down. I actually don't even look at the answers. I tell people that, which is really weird because some people just write down answers, and I'm like, that's actually not what I'm grading. Liars. It's so dumb. Anyway, what you'll do in this, and we'll set this up just like we did our conversions way, way back, and that is to take something like that, what did I say, 35 moles, and I'll say 35 moles of cellulose. Then you should notice that this is going to look pretty darn similar. And then, whatever I want to get rid of, I put that on the bottom of my equation. And whatever I care about, I put on the top. So in this case, I said CO2. And yes, you should be writing this down if you are not. And this is like the gist of what you're about to be doing. Do you catch why I'm doing what I'm doing here? So that this cancels out this, and this cancels out here. And now I use that ratio. We call this the mole ratio because it's moles. Again, not really creative. So I take whatever number was in front. So in front of the CO2, it was a 6. In front of the C6H10O5, it was a 1. And now I just do my math. This is only in case you're watching, Jack. See it? Just for you.
Shut up, just so you can see them.
He wouldn't see it. He wouldn't make it that far. He'd get bored. Stop watching. See how it works? So using the mole ratio, like I said, is probably the easiest part of doing this, but it's actually the biggest part of the concept. Is figuring this part out and using that mole ratio. That's kind of what I want to work on today. So I've done, I'm going to throw some problems at you that you can try out with you and your partners. Then my thought was, before we run out of time, what do you think, maybe the last 10 minutes? I'll do a quick one-over of the final to make sure that there's no like weird surprises for you. Does that make sense? So like if there's odd stuff, because I was thinking last night, I'm like, ooh, I wonder if they remember that we did like conversions way back at the beginning. Like I wonder if they remember things like what a meter is. So I figured maybe we should talk about that last 10. Does that sound good? Yeah, people wouldn't mind that. Okay, now let's get some problems up here.